All right, let's shift gears and talk about cubes. All right, so with quadratics, there were 3 special patterns. With cubes, there's 2 special patterns. One is when you have 2 cubes and their sum, and one is when you have 2 cubes and their difference. So it's either going to follow the a cubed plus b cubed pattern, or it's going to follow the a cubed minus b cubed pattern. And their factoring is very similar. They're just going to have slightly different signs. So it's always going to be a binomial times a trinomial. Okay? So the first one's binomial is a plus b, and the difference of cubes is going to be a minus b. All right? For the trinomial right here, we're going to have a squared minus ab plus b squared. And for the trinomial right here, we're going to have a squared plus ab plus b squared. Okay? Now you guys are really good at looking for perfect squares, but are you good at looking for perfect cubes? Okay, most of your perfect squares you guys have memorized, and only a few of the perfect cubes you probably have memorized. 1 cubed is 1, because 1 times 1 times 1 is 1. How about 2 cubed? 8, because 2 times 2 times 2 is 8. How about 3 cubed?
27.
Okay, anybody know 4 cubed?
64.
Okay, why is 64 a tricky one? Because it's also a perfect square. It's a perfect cube and it's a perfect square. Okay, so it may, when you see 64, it could go either way, right? What is 5 cubed?
125.
125, okay? So if you don't know how to, if you don't have them all memorized, then you can do them on the calculator. So let me show you how. So if you have 8 to the 3rd power, you can use this, what we call a caret button. You say 8 to the power of 3, and it gets you 512. How many of you have that one memorized? Okay. All right. What if you saw the number 512? Would you know right off if it was a perfect cube? No. Okay, so you would want to test it on your calculator, right? So above the square button is the caret, and above the caret in light blue on this calculator is the x root. So you have to tell what root you want. You want the 3rd root, so you type 3. This calculator, you have to hit second, and then it has the little x root. That's telling the calculator that you want the 3rd root of, then you type 512, hit the equal sign, and it's a perfect cube. Okay, if you get a decimal, not a perfect cube. Okay, you want it to end up a nice number for you. Okay, then you know it's a perfect cube. All right, you also need to be able to recognize algebraic perfect cubes, like x to the 3rd is a perfect cube, and y to the 3rd is a perfect cube. How about p to the 6th? That is a perfect cube because p to the 2nd to the 3rd power is p to the 6th, right? How about n to the 9th? That is a perfect cube because n to the 3rd or cubed is a perfect cube. All right, so let's try 2 examples. I'm going to do one of each of these 2 patterns. So one of the sum of cubes and one with the difference of cubes. All right, example number 3. All right. Example number 3, we have negative 8u cubed minus v cubed. All right. So just like with quadratics, with cubes, the first thing you want to look for is GCF. Is there a GCF for these 2 terms? So trick question. When you first look at it, you think no, but I'm going to tell you yes, there is. There is a GCF. What should I factor out? -1. Okay. Okay. If there's a negative out front, you want to factor out a -1. So that's going to leave us with 8u cubed plus v cubed. Okay. So at first it looked like it was going to fit the difference pattern. It's not going to fit the difference pattern. It's going to fit the sum pattern. Okay. So we're going to look at this first term, and we want to take the third root of 8u cubed. What is the third root of 8u cubed?
2u.
2u. Everybody see how we got 2u? Okay, that 2u is going to become our a. Now we want to take the third root of v cubed. What is the third root of v cubed? V. That is our b. Okay? So using the pattern from right here, you can barely see it. Using the pattern from right here, we're going to use 2u for our a and v for our b. First time we write it, we're just going to plug it in. Second time we write it, we're going to simplify it. Okay? So, for the binomial, the pattern says a plus b. So we're going to have 2u plus v. That one's pretty nice. We won't have much simplifying or any simplifying to do with that one, right? Okay, now we've got our trinomial. For our trinomial, we want a squared. So I'm going to take the 2u, put it in parentheses, and then square it. Why did I put it in parentheses? So I remember to not only square the u, but to also square the 2. Okay, because if you don't put in parentheses and you put the square, it looks like it's just 2u squared. And some people forget to square the 2. So put in parentheses so that when you go and simplify on the next step, you square both of them. Okay? All right. Now the pattern says minus ab. So minus a, which is 2u, times b, which is v. And then the third term of the trinomial says b squared. So plus v squared. Okay? Now we're going to simplify. So the binomial is good. 2u plus v. No simplifying there, but we do have some simplifying in the trinomial. So 2u squared is 2u times 2u, which is 4u squared. The second term is minus 2u times v, which is just 2uv, plus v squared, which is v squared. All right, any questions on example number 3? Yes, sir. Oh, yes, thank you. You caught it. Squeeze in that -1. Oh, I'm just going to write the equal sign out here. Make that a big negative sign. Make sure you bring down a GCF if you haven't. Thank you. All right, and example number 4. We're going to have 1 minus 64p to the 6th. Is there a GCF for example 4? No. Okay. And we have a 64 in there, so could it possibly be a square?
Yes.
Yes, but it's also a cube, and p to the 6th is a cube. So we need to take the cube root of 1, which is 1. So 1 becomes our a. And then we need to take the cube root of 64p to the 6th, which is
4p squared.
4p squared. So that becomes our b. Right? So this is going to follow the differences of cubes pattern, which starts with our a minus b. So 1 minus 4p squared. Our binomial is good. We won't even have any simplifying to do. Okay? Now let's do our trinomial. So our trinomial is going to be a squared. So we're going to take the 1 and square it. Then we should have plus ab. So 1 times 4p squared. And then plus the b squared. So plus 4p squared squared. 4p squared squared. All right. Now we can simplify and we'll be done. Okay. Binomial's good, already simplified. Now let's tackle that trinomial. So 1 squared is 1. 1 times 4p squared is 4p squared. And the only tricky one here is the 4p squared squared. So we need to square everything. What is 4 squared? 16. And what is p squared?
4.
P squared squared. P to the 4th. All right. Finish copying that down.